Good morning, good evening, and good afternoon to everyone who joined us today. My name is Dmitry Naumov. I'm a solution architect with Icomatica, and I've been working with Icomatica for almost 6 years now. And today I would like to talk to you about quality of the applications and tools that Icomatica use internally for building quality applications and tools that are available to you as third-party application developers. Uh, so first of all, we'll talk about QA procedures, so quality assurance procedures that we use internally. We'll take a look at different levels of QA procedures and different types of QA procedures. Uh, then we'll talk about QA procedures that we have implemented for ISV solutions and about our certification program. And after that, we will touch on the specific part of QA procedures, the important part. It is automated tests. We will compare different types of automated tests. We'll see what pros and cons each type of the tests has, and then we'll review which uh, technologies and which tools we provide for you and we use internally to build these tests. And then we'll talk specifically about two types of automated tests. We will talk about contract-based API tests, and we will talk about a unit tests framework, which is relatively new. So that would be uh, not completely new session. We've already talked about unit tests framework during the summit developers session. Today I will have more detailed walkthrough. I hope you'll like it. Okay, so uh, let's start. Let's first of all take a look at the classic chart that I'm sure you've already seen somewhere. That's a chart of cost of fixing a bug related to time to find that bug. First of all, uh, you probably know that if you find the bug earlier, uh, it is easier to fix the bug. And if you find the bug later in the development process, or maybe during the QA procedures, or maybe even customer finds the bug, then it significantly increases the impact of that bug, and eventually it increases the cost of maintenance, and the cost to fix that bug grows. And we'll talk about specific reasons why that happens a bit later. So let's start with simple and the most uh, early type of bugs that are these are bugs found during the development. So during the development, a developer can either just find the bug by observing the code, or the developer can rely on some static code analysis tools or on compiler to help him or her to find a bug. So if a bug is found during that stage, during the writing the code, it is easy to fix the bug because the code doesn't have a lot of dependencies yet, uh, and the developer is in the context of that code. The developer knows what code does, so that code is fresh in developer's memory. So developer can easily fix that bug, and basically that bug costs us, well, almost nothing, because uh, it is can be fixed like in 5 minutes usually. So to help the developers with finding that kinds of bugs, we have our static code analysis tools. Specifically, we have Accumulator, which is a Visual Studio extension that you can install in your Visual Studio, and it will highlight common errors and common uh, issues that you may face during the development for Acumatic ERP. For instance, it may highlight wrong event declarations. It can highlight unmatching field types in the data access classes and stuff like that. So the tool really highlights the errors real time. Once you write the line of code, the tool verifies it and gives you a warning or error if something is wrong with that line. So that's the most fast way to find possible issues. And internally, we use Accumulator during our development, and we also use Accumulator during the build process, and we use it in our continuous integration procedures. And we'll touch on that in the next session today, which Sergey Nikomarov and Evgeny Afanasyev will provide. They will talk about Accumulator and how to implement Accumulator verifications during the build or during the continuous integration procedures. So the next step on the chart is unit tests. So unit tests are very fast and small tests that developer can write and the developer can execute during the development. Although it's still during the development process, developer first needs to finish the block of code he or she is working on to be able to compile the program and to run it and to run unit tests. So usually unit tests run within seconds, and it allows developers to see if their changes are affecting any places that are covered by unit tests, basically during the development cycle. So the code may not even be committed anywhere yet. The developer can run these tests, and the developer will see if something is broken, and the developer can still fix the code pretty fast, and the developer sees the specific place which is affected by his new changes or her new changes. And we'll talk specifically about unit tests in the end of that session. So the whole second part of the session is related to unit tests. So we'll touch on that more. The next step in that process is regression testing. Internally, we have about 2,000 regression tests, which are functionality tests written in our Test SDK. So these tests, they allow us to run the system as user would run it. It allows us to basically execute user actions in browser and see if the system behaves the way we need it to behave. However, if the bug is found during that regression tests, first of all, to run regression tests, we need hardware, we need environment setup, so it takes time to execute this test. So it takes more time to find the bug. Another thing is that once you see that system behaves in a not expected way during regression testing, you don't really know which particular line of code is causing that issue. So you, as a developer, need to go back to the, first of all, to analyze which change breaks the behavior, and then you need to go back to the code and fix the code. And you may even not be working on that piece of code anymore. Maybe you know about that like the next day, so you almost forgot some things about the code, you are out of context already, so it will take more time, more development time to fix a bug. And of course, it takes some machine resources to run these regression tests. So it takes more time and eventually more money to fix the bug on that stage. Then the next step in the process is code review. Once the system works as expected, according to unit tests and according to regression tests, we can have a code review, and the code review will consume more valuable experienced developers' time. For instance, regression tests, we mostly consume machine resources, which is not that expensive. For code review, we need humans and real developers to look at the code, and it costs more. But still, it is very important part of the quality assurance, because on the stage, experienced developers can see future possible problems, potential problems that unit tests or regression tests cannot find. Maybe there are there is a lack of customizability. Maybe the code is not extendable. Maybe the code is hardly maintainable. So during the code review, developers may identify these kind of issues and point out these issues. And the final step in that process is a manual acceptance testing. So for each new feature, we have manual acceptance testing implemented in Ecomatica. So QA analyst or business analyst takes the build and manually tests the scenarios that were implemented. And of course, during that stage, they may still find some bugs. And well, manual tests require a lot of time from business analysts. So it takes more time and it takes more money to find a bug on that stage and to fix the bug on that stage, because when you fix the bug on that stage, you then need to get back to the first step, right? And you need to go through all the quality assurance procedures again to make sure you, when you fix the bug, you don't break anything else. So that's kind of a classic chart. And all these steps are important because all these quality assurance procedures allow you to find different kinds of errors, different kinds of bugs, and different kinds of issues. And we have all these steps implemented. And during today and tomorrow, we'll share with you our experience on how to implement all these steps in your development process. But we are very environment and ecosystem dependent software, right? For the user, it doesn't really matter if ERP works fine if integration of that ERP doesn't work, or if extensions that user needs for their business processes do not work. Still, user cannot have the experience they expect. So it is important for us to make sure the quality of ISV solutions is also good. So that is why we have ISV certification procedure, during which we review the ISV solution, whether it is integration or extension. And we have several steps that we perform to make sure the quality of the solution is good. So let's take a look at these steps. First of all, we again have static code analysis tools, and that's actually the same tool. we really recommend all the developers who work with Acumatica code to install Acuminator and to use it during the development process. It allows you to find errors as early as possible and spend as less money on them as possible. So again, when we receive ISV solution for review, we use Acuminator internally to verify the code and to see possible errors in the code. The next step we do is a documentation review. Documentation is a very important part of the product because if user do not understand how to use the product, if user uses the product in a wrong way, it doesn't really matter if the product works because, well, the user workflows does not. So it is important that for each ISV solution we have sufficient documentation and we have properly described processes so the user can be sure he or she does everything as expected. The next step in that process is automated packages verifications. And starting from Acumatica ERP 2019 R1, we have validations built in the product. So on the customization project screen, you actually have a button that you can click to validate project, and the tool will validate database mapping for your customization project. It will validate attributes on your fields in the customization project. So we really recommend you to utilize that tool during the development. But again, we also use that tool for review of ISV solution and during the certification of ISV solution. Another thing that we have here is requirements validation tool, which allows you to make sure your ASPX pages schema is correct. So, and you can hear about that requirements validation tool later today during the Sergey and Evgeny's session. Another thing that we do for integrations, we review API requests incoming to Acumatica. So we actually have a proxy server set up on our test environment. So we ask you or whoever provides the solution for review to run their integration with our test server, and we review all incoming and outgoing API requests, we review all the data that flows, and we review if the solution requests the data it needs and doesn't request the data it doesn't really need, and that the solution doesn't affect performance of the core product. So the next thing that we have is, of course, code review, manual code review. Static code analysis tools are good tools, but still static code analysis could not find all the possible issues in code, because sometimes developers can be very creative, right? And it is only possible for another developer to identify the idea behind this and to identify possible flaws in that implementation. So we perform manual code review here as well. And finally, we perform manual testing of the solution. We test the scenarios described in documentation, and we make sure nothing strange and nothing unexpected happens during that manual testing. So again, we have all these procedures implemented for solution certification. But even if you're not sure that you need certification right now, you still want us to verify the solution, You can ask that. You can ask us to do that. So you can we can run automated tools on your package to make sure your package meets our guidelines and that it is working fine. Uh, to do that, you can contact me or you can use certification@informatica.com email, and you can request verification of your package. So these were quality assurance procedures that we have internally for both our own product and for third-party products. And as you've seen, the important part of these procedures is automated testing. And as for automated testing, let's review it in more details and let's talk about different types of tests that exist, well, generally in software development and specifically in development for Informatica ERP. First of all, let's categorize automated tests into several categories. On the one side of the spectrum, as we've already seen, we have unit testing. So unit testing allows you to, first of all, have tests that developer can execute, and the developer don't need to wait till infrastructure, till the needed infrastructure is free, till the QA engineer runs the test. Unit testing usually is implemented right within the solution, and developer can run these unit tests himself or herself right in the Visual Studio or any other integrated development environment. And the developer can get requests, can get results of these tests as soon as possible. It really takes seconds to run these tests. On the other side of the spectrum, we have system testing. So system testing is testing that affects the entire system, that tests the system as a whole part. So important thing here is to test real user scenarios and real user experience. So for instance, in our case, we need a web browser running, we need real web browsers, and we need real user clicks in these web browsers to test the system as a whole part. And of course, we need database, we need environment, we need hardware to run these tests. So, and this is a spectrum of different kinds of tests. And of course, between these two categories, we have a lot more intermediate categories that we can talk about a bit later. So what does it mean for Informatica ERP specifically? So for Informatica ERP, we have basically three different types of tests and three different tools to test the application. First of all, for unit tests, we've recently introduced unit tests framework, and that is what the second part of the session is about. So I will go through the creation of simple unit tests, and we will talk about specific advantages that our unit test framework provides. So right now, let's just quickly touch on that. First of all, as I said, unit tests are running fast. Second, tests are executed during development, and tests are written during development. So the same person who writes the code can also write the tests for the code. And also, advantage here is that these tests are testing the exact function of the system, so you immediately see which method or which unit of the system returns the wrong result. On the other hand, unit tests does not test real user scenarios. So you can't really be sure that even though all your parts of the system works as expected, you cannot really be sure that the system as a whole piece works as expected. So for that, we have Test SDK, and as for Test SDK, Patrick Chan will have a session tomorrow, so you can attend that session to learn more about Test SDK. So pros here is that Test SDK emulates user behavior and emulates user interaction with the system. So you really see the browser that is receiving some clicks, and you have the database where all the changes are reflected. So that's real system behavior. However, on the other hand, we have specific requirements. So for these tests, we need database, we need hardware, so it takes a lot of time to, first of all, set up all that, then execute the test itself, because it works through the user interface and it can't be too fast. And of course, it's hard to identify the exact line of code that causes the issue, because maybe it's not a specific line of code, maybe it's it is caused by different lines of code, many different lines of code that just doesn't work good together. So it requires investigation to locate the bug. Then in the middle here we have contract-based API tests. So I put these tests in the middle because, first of all, it is real integration test. So these tests are testing the system as a complete piece. However, it doesn't go through UI, so it doesn't really test the user interaction with the system. However, you can still test, for instance, complex calculations. You can still test complex scenarios. And because it doesn't run on the UI, it is actually running faster than Test SDK tests. So if you write these tests in a proper way, it is possible for developer himself to execute this test during the development and get the result fast. However, for these contract-based API tests, the developer who writes these tests should be familiar with Acumatica APIs, and which is more important, the entities you would like to test should be included in the web service endpoint. So if you don't work with the default entities and you want to test your custom entities, probably you would need a specific web service endpoint. And of course, it again requires database and environment. But as I said, if you implement these tests properly, still this test may be useful for both testing the system as a whole piece and testing during the development. So let's take a closer look at these contract-based API tests before we go to review of unit tests framework. So the idea here, the idea of contract-based API tests is that you take standard Acumatica APIs, REST or SOAP based, and you execute some scenarios, and you can actually execute these scenarios using any programming language that you prefer that can send requests to REST or SOAP APIs. So you implement this request. You can even use Postman for that, and then you verify the response that you get from the system. So normally the test that creates a couple of documents and then, for instance, releases these documents and checks the resulting values can be executed in several seconds. So it's still pretty fast. It's not that long as Test SDK tests. And another thing about that is if you really write these tests properly. So for instance, if you do not rely on the data that is already in the database, but you set up the data needed for the test every time from scratch within the same test, in that case, you can run the test on the database, on the specific database and specific environment several times. So it is very good. It is a very good tool for developing complex calculations. For instance, if you have 25 different combinations of tax settings that you all want to check, you can really code all of them in the code in the contract-based API test, and the developer can run all 25 calculations within, for instance, a minute. So that way, the developer who is working with on altering the tax calculation can be sure that he or she only fixes what he or she needs to fix, but not break anything else. We can have a separate session about contract-based API tests if you'd like to. So please leave your feedback, and if it's a topic that you would like to see there, we will have a separate webinar related to that contract-based API tests. And now we can switch to unit tests framework, and we will go through example of unit test on Acumatica unit test framework. But first of all, let's discuss what Acumatica tests framework provides and how you can work with this test. So first of all, for Acumatica world, the minimal functionality piece that we can consider is actually a business logic container itself. So the pxgraph object itself. The reason here is that piece of business logic that you would like to test may be split between different events. It may be split between different attributes, and it is not really easy to isolate it. So the minimal piece here, the unit that we are going to test with our test framework, is usually pxgraph. It doesn't mean that it is impossible to test a smaller piece, for instance, one method of the graph, or for instance, one method of the attribute. It is possible, but usually the standard way would be to test some pxgraph behavior itself. Another thing that is important about test framework is that the code you write for your tests is actually very similar to the usual code that you write to manipulate with graph objects, and it is very similar to like usual Acumatica framework code. So actually the developer who is familiar with Acumatica framework can start writing unit tests without any additional guidance. And then the important part of a unit tests framework is that it doesn't require a database, it doesn't require any environment. So the test runs with the code, and that's all. So let's talk specifically about that part, and let's clarify why we need that. So let's imagine we want to test some method. But usually any method in the system is dependent on other methods. So it may either use data from other methods. It may execute other methods to change some data. So usually it has a lot of dependencies. But we don't really want to test all these other methods. We only want to make sure our new method that we are working on, or our fixed method that we are working on, works fine. We don't really want to know whether other methods are working. So for that, we would need other tests. So in that particular test, we only need that particular method to be tested. So to remove the dependencies, we have a mocking mechanism that actually just provides sample data for the method. So it emulates data retrieval, for instance, from database. It emulates data retrieval from user interface. So that way you can test your method in the static environment without any dependencies. So you can be sure that the thing that you test is actually the unit that you want to test and not something else. And of course it is important because database connection and database setup is a long procedure. It takes a lot of time, so we don't really want to have any database. We just want to have to work with simple data to test our units. So now when we understand mocking and why it is important to work with fake objects instead of working with real database and real dependencies, let's switch to an example and let's take a look at what we need to do to implement unit test using Acumatica test framework. So basically, there are several steps. First of all, you need to create a unit test class. Then you need to set up the data you need for test. So you need to set up that sample data. Then you execute the actions that you want to test. And then you verify the result of that action. And we'll look at the real scenario that we would like to test here. So let's imagine we need to test a simple business requirement. So the requirement that we are going to test today is the following. On the bills and adjustments screen, we have a vendor selector. Once we select a vendor from the list, all these values are populated from the vendor. So these values are defaulted from the vendor. And for instance, if we have different currency in the vendor, let's say in the vendor we need SGD currency, which is, I think, Singaporean dollars. We'll see that once we select that vendor, the currency is changed to a different one. So we would like to test that simple behavior. When you select a vendor, you see the currency changed in the document. So let's see how we can do that. So first of all, what we need is to include some references in our project, and that references are actually the things that allow us to, first of all, utilize unit test framework. And to utilize the framework, we need PX data, and also we need px.data.unit. Besides, we would like to test AP screens, and for that we need px objects.ap namespace, and we need fix objects dot trail namespace, and we need fix objects dot look here, and we need this too. So here are dependencies that we need to implement that test. For test itself, first of all, we need it to be a public class, and then we need it to be derived from test base. Oh, by the way, another important thing is to use xunit, which we use for running these tests. Okay, good. Now we have all the dependencies we need, and we can start writing our tests. Well, first of all, as I said, we need to set up sample data. So to set up the data, we need several pieces of logic here. First of all, we need to mock some dependencies that we have in the code. So in the code, we usually have services which we register with dependency injection. And for the test, we don't really want real services to be executed. We want service mocks to be executed, which we provide as a part of px.objects.unit namespace. So we use fin period service mock and currency service mock. So that's for register services method. The next thing we do, we create a prepare graph method. So the prepare graph method uses specific method to insert setups. So as you know, for each Acumatica business logic container, for each Acumatica PX graph, we need some setups to for this business logic containers to run properly. So you can use that syntax setup AR invoice entry, and you can insert required setups, required preferences when you create that graph. So that's what the method does. Then the next thing would be to create our actual test class, and our actual test class would look like that. Here we see a fact attribute that indicates that this is a test, and that test should not throw any exceptions, and that test should basically have all the assertions that are in here to be true. So first of all, let's give it a good name so we understand what the test does. So our recommendation is to use test underscore what it does and some additional information. So for instance, in my case, that would be test defaulting from carry ID from vendor. And for that test to run, we need to, first of all, prepare our graph object. We use that method to prepare the graph object. Then we still need some data to be inserted. So we still need some data that we will work with. So first of all, we need currency, and then we need vendor. Here it is. So we use that graph object, and we use caches of specific type, and we use insert method that you are probably familiar with to insert new currency list object and to insert new vendor object in that caches. So here for a unit tests framework, instead of selecting data from database, we actually insert data in the caches directly before we execute the test. So all the data that we need during the test execution, we need it to be inserted in the caches before actual action that we would execute. So here we create a vendor with carry ID, with account name, and we have the carry object which indicates the currency itself. So, and that is all. Our preparations are complete. Now we can actually execute the thing we want to execute. So here, what we do, we insert a new document in the graph, so the AP build document, and then in that build, we set vendor ID to be equal to vendor ID of our new vendor, and we update the document. Again, that code is very familiar to what you usually see in regular Acumatica ERP code, so it is easy to work with that code. And then finally, what we need to do, we need to check the result. So we need to use special assert method, and we need to check if the currency in the bill is equal to what we expect it to be equal. Good, now we can rebuild the solution. And now we can, and we see the new test here, right? So you can see that I now have 3 tests, and I can run that test. It takes some time, and in a second we'll see that the test is green, which means it is, that statement is correct. So let's not wait till it finishes. So as you can see here, okay, it took 23 seconds to execute. So it is because it probably reloads some DLLs and caches. So as you can see, it may take like 16 seconds, 15 seconds, but if you run them regularly, it will even take less time. So that's a simple example of unit test. I hope you liked it, and I hope you'll be implementing these tests for your products. Okay, well, that was my example. I hope that was useful for you, and I just want to summarize all of that. So today we've seen different types of quality assurance procedures, and I want to emphasize that all types of these procedures are important. All these procedures are something that you need to have quality solutions. You cannot rely on one procedure. You really need to support quality on all levels and all steps of the development. We provide different approaches and we provide different tools, and we share these tools with you. So all these tools that we've talked about are available. Test SDK, unit test framework, contract-based API tests, Acuminator or requirements validation tool, automatic validations in the product. All of that, it is available, it is there, it is waiting for you to take advantage of that, to utilize it, to leverage these tools. And I just want to put some useful resources here, useful links. So all the code that I showed today is available on GitHub. You can download Test SDK and Test SDK guide using that link from builds.acumatica.com, and you can download ISV certification guidelines from our portal. So these slides will be available for you, so you will be able to click all these links later. And please don't miss our next sessions regarding quality and tools that are available for you. So today at 12:40 p.m., Sergey and Evgeny will talk about Accumulator and requirements validation tool and continuous integration. And tomorrow at 10 a.m., Patrick Chan will talk about Test SDK. So please be sure to visit these sessions. Hope that was helpful and hope that was enjoyable. I will be answering all the questions during our break, and well, I will be answering all the questions right now, and if we have more, I will be answering them during the break.
Thanks, Dmitry. Yeah, so why don't you answer some questions live until 11:25, and then I'll start the break at that time. So you did a great job. You got us back on schedule. Thank you.
Welcome.
Do you want to read the questions? Or do you want me to read the questions and then you answer them?
I will read them.
Okay, great.
Okay, so the first question we have is 2,000 regression test cases seems very low for an architecture like that. So just to be clear here, each regression test in that case is testing the complex scenario. So for instance, the scenario may be like user creates a sales order, then user creates a shipment, then user, for instance, cancels the shipment, user goes to the sales order again, recreates the shipment, maybe creates several shipments, then confirms the shipment, then releases AR documents, and in the end the test verifies that all the data in, for instance, GL tables, all the data in the inventory tables is correct. So this test, each test covers not some screen, for instance, or not some particular function of the system. Each test covers user scenario, complete user scenario. So, well, from my point of view, it is impressive number, and our test coverage, well, I can't say exact number, but from my experience, it is a very significant the test coverage that we have right now. Okay, the next question is, will there be an option for certification for customers? Well, good question, thank you. It actually depends on different things, and I'm not really sure what you mean by certification for customers. So if you are talking about like developer certification and trainings that we have, I think we had some activity around that, and maybe it is available right now. So that's more a question to Mark. I'm not sure. As for customizations and solutions, well, we would love to have validations and code review and certification for customer customizations. Unfortunately, it takes a lot of time, as you can imagine. So manual code review takes a lot of time, manual testing takes a lot of time. So here we cannot really accept all the customizations, and we cannot really review all the customizations. So you need to be an ISV partner to be able to send us your code for review. If it's something small, right? If it's like one graph or something like that, you can still send it if you have a dev support subscription. So you can still send it to dev support and we'll review it.